done is your vocab. Okay, this should all be filled out. And then last time we did part A, mystery cubes. So now today I'm going to give you data for part B. And all you need from me is the mass, and then we'll get the volume for each piece, and then we should be good to go. Everything should be running. Okay. All right, so let's do the first one. So just make sure at the top of your page it says B. Yes? What did you say? I can't hear you. You didn't do the second? Do you have this? Okay, let me give you one. You should have had it on your desk. That's weird. So the first thing that we're going to be measuring is a piece of copper, which is kind of, if you remember what I showed you last time, it's really shiny. This is what pennies are made of. And this is our first irregularly shaped object. Okay? So does anyone remember why would we have a different way to get volume for this versus when we did the cubes? What's the reason that an irregularly shaped object requires a different way to get the volume?
Because it's not like shaped, so you can't like go over there and measure anything. It's irregular.
Exactly. Yeah, I can't use a ruler to get the volume of this. There's like little nooks and crannies in there, and it would take me a million years, and I probably still wouldn't be accurate. So an irregularly shaped object is something that you can't take the density of it with a ruler by measuring length, width, and height. So today we're going to get the density of three separate things. The first thing is copper. I'm going to make sure the units are in there for everything. So the mass should be in grams, milliliters. And your density's answer should be in grams over milliliters. Make sure you're showing work for everything. So the formula you're going to use is density equals mass over volume. And then you're going to substitute and solve. And then we'll do the next object in a second. Okay? So my first thing I'm going to do is I'm going to get the mass. So just like always, I want to make sure that my scale is zeroed out before we begin. So front row people, can you vouch that that's balanced? Yep. So I'm going to place my copper on the pan. Okay, slide this over, starting with the biggest one, but it's too heavy, so I'll bounce it back. And then slide the tens over. Pretty close there. But it looks to me like it's a little bit heavy. So I'm going to back it up to the 60. So our first number is 6. And then we have 9. Okay, so 6, 9.7. Okay, that's our mass. So I'll do the mass for all of them at once. Do I want to do that? No, I don't want to do that. Okay, so now I'm going to slide this back, zero everything out, and then we're going to get the volume. So we're not using a ruler this time, we're using our graduated cylinder and a little bit of water. Okay? So the first thing I'm going to do is just pour in some water into my graduated cylinder, which makes a lovely peeing noise. And I'm going to make sure that I get low so that I can read what it says on the side. I'll put that back up in a second. Okay. So our starting value is 150 milliliters. Okay, so that's my volume before, 150 milliliters. And it's before I put the sample in it. This will be after I put the sample in it.
What would remind us what process this bunch is doing right now?
Yeah, what is this called?
Object.
Good question, Mr. McGuire. What is this called that I'm doing? After I put the sample in it, think about what happens to the water. What do we call that, Giancarlo? Displacement method. Good, exactly. So if you don't have a definition for this, I'm kind of demonstrating it right now. After this, you should be able to put one in your own words. Okay? So we're starting with 150, and now I'm going to tilt my graduated cylinder on its side, and I'm going to slowly kind of slide this in there, because if I don't, I'll shatter out the bottom and have a really bad day. Okay? And so my finishing, 150, looks like about 158 milliliters with my sample in it. 158. So if I want to get the volume of just my object, I need to subtract the water and make it go away. So what is the volume of my object? Yeah, 8 milliliters. Good. And so now when you want to get your density, you use your mass and you use your volume of object to get your density. So 69.7 grams divided by 8 milliliters. Okay, so go ahead and take a minute right now and do that calculation while I get set up for the next one. So whenever you're ready, you can start copying down the data for the next one. Okay, so the next thing that we will be getting the density of is a piece of quartz. If your birthday's in February, you have a variation of quartz as your birthstones, amethyst. Amethyst is just purple quartz. This is just white, regular quartz. It actually comes in like 5 different colors, which would probably affect the density slightly because there's little impurities in it. But we'll talk about that when we get to rocks and minerals. So let's take the mass. I zeroed out the scale, and I'm going to place my specimen on the pan. Okay, so I'll move this one over, but I kind of know that it's going to be way too heavy to start with. So let's move over, starting with the tens. Ooh, pretty close. It's a little bit, that looks actually pretty good. 10 grams, right on the dot. Okay, 10 grams. So that's our mass. Our volume, same way as I did before. So I'm going to take my water, pour it into my graduated cylinder. Our starting is 110. So that's our before, 110 milliliters. And now let's see what it is after I place my specimen. Okay. So after it's about 114 milliliters. Which means my volume is, 4 milliliters. So I'm going to use this volume and this mass in order to get my density for quartz. So 10 grams divided by 4 milliliters, and you can calculate your density here.
just want you want them rounded to one decimal place when we do this?
They can round to the tenths place when they get to their final answer, especially if it's like a long decimal and that's such a pain. Okay, so once you finish doing your calculation, you could set up the third object, which will be garnet, which is not the same thing as granite, although granite can sometimes have garnet. Garnet does not have granite, which is confusing. Don't worry about it. Mass should be in grams. Density equals mass over volume. And just making sure you have the right units. Okay, placing my garnet on the scale. Okay, looks like we have 10.5 grams. And now we can calculate our volume. Starting with 130 milliliters. So that's our before. And then let's see our after. Looks about 133 milliliters. Which means the volume of my object is what? Good. And we're going to use this number and this number to get our density. Okay, so far, as of right now, you should have vocab done, part A done, part B done. So all you have left to do is part C, the questions. So I think it would be nice to go outside to do that, but there's only about 15 minutes left. So I'll take a vote. Would you rather just finish it up in here and probably get more time if you just sit here and do it, or would you like to go outside? Okay, so raise your hand if you want to go out. 1, 2, 3, 4, up or down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then if you would rather just finish it in here. 1, 2, 3, 4. Okay, we're gonna go out. So, what you need to bring for outside: clipboard, lab, calculator, pencil. If you didn't finish your homework and you think you'll have time for that, you can bring your homework too. Okay, so we're going to go where we normally go, remembering that if you're sitting within 6 feet of somebody, you need to keep your mask on. Okay, and try to give each other some space. If you finish early, you're not walking around and touching people. And I don't know why everybody's out of their seat already. Okay, and so we'll end our stream. Well, I'll leave the stream just in case if it'll get closed out. Shouldn't do it. And just FYI, this is the last period we're working on this lab. Okay, so whatever's not finished in class becomes homework, and it has to be on Google by Friday. Does that make sense to everybody? Everyone's on the same page? Okay. So let's head outside. Let me just grab my phone and my keys and water. Okay? You guys can come out. Just make sure you're quiet as you walk in the halls. Mr. McGuire, can you do the last one out?
Yes. I would have to bring in the book for it to have it. Go back in, have both turns in it.